Hello. Today we are going to see the open routine and the algorithm. There are some conceptual things that I am yet to give to you that I'll continue tomorrow. But today let's have some implementation in open so that you'll be able to understand about what I talk. Little implementation and then a lot of conceptual things coming behind that. So in open, what do you have to do? Let's go to the Jamboard and have a relook at the device driver architectural diagram that I have given earlier. There it is. Another one we have to open. Hold on. Here it is. See, open. I have spoken a little bit about open. Step number 1, step number 2, step number 3, step number 4, 5, 6 AB, then 7, 7A, 7B, 7C, 7D. These steps, So very first thing that has happened is that there is a device file that has to be identified, that has to be opened. Yeah, very good evening. So we have a device file that has to be opened by the application. So our application that we have written the other day have an open routine. Where it is? There it is. So what have we done inside this is we have given the open call, and we have given the open call. Where is it? We have given the open call. Did we give the open call? Yeah, there it is. Open call, and the file name. File name is supplied at runtime. Okay, and the file name that is supplied at runtime is the one that we create using mknode as specified in the script. Build driver, insert driver. At the insert time, we specify that the node is this, and after that, when we do test with applications, run app. At this point of time, we are specifying that the name of the device is mydev. This is the name of the device, and an entry will be created in the file system for a device file called mydev. And when you run the application will use mydev. See, when we are running the application, here we run the application, and the application will open file name which is mydev, which will supply at runtime to the open routine. Here, inside this block, mydev will be opened, and the mydev is created with a character device, the given major number, and the minor number we have 0 to 19. But we have chosen only one of the 1920 devices to work with. Okay. Now the open system call will come, and when the open system call will come to your device driver, the open system call will be mapped, because it will identify that, oh, this device has a device ID, dev_t. It is not 000. The device ID has a major number and the minor number. Using major number, control will jump inside the device driver, and now the control will go to file operations according to the steps given here, and try to find this open routine and the associated open routine pointer and the open routine. So we are inside this open routine now, and we'll work inside this open routine now. Normally the open system call would have gone to the system call routines, but using the device ID, major minor number, we are able to reroute it to our own device driver routines, which will go through the device driver and try to access the hardware. Okay, so we are able to do that. We are able to map. I hope everybody is able to map and nobody is lagging behind in this, right? So let's proceed further and try to implement open routine. Few steps.
Excuse me, sir.
Yes, who's that? Ravi, tell me.
Yeah, Ravi this said. Sir, can you explain this MK node structure? Because actually I tried to find on terminal the function was different, and I
You tried to
this
find where?
from terminal man MK node.
No, no, no.
It was a function.
You have to do man 8 mk node. Okay, no manual entry. You
So,
don't have it here. Mk
so see,
node. You don't have it. So this mk node is going to create an entry in the file system. Okay, where make block or character special files. It will make a special file in the file system, which will be a character file, which will be a device file, which will be connected to some inserted device driver, and further which will be connected to some inserted device driver using a major number, and further connected to some hardware device using the minor number. So this device file that will be created using mk node, in our case it is created using this command. The device file name is mkdev. When you create this device file will be connected to the device driver using the major number, and further to the device using the minor number provided through the command major number and the minor number. And C says that this file is going to be your character device file. Now the application will be able to see this file in the file system. Okay, and then the application will be able to give the open system call, where the file name will be the same file name mydev, and the application will open this file as just like any other ordinary file, but because of the presence of the major and the minor number, the control will go to your device driver routine instead of the ordinary system call routine. So we have already done that, and we are here. So honestly, tell me, who are the people who are not able to implement the open system call driver mapping till now? Okay, that seems you don't need my help further. Okay, so you don't need my help in mapping, as if you are because everybody is able to map. So let's go ahead and start implementing the open driver routine, which is empty now. Now in open driver routine, what you have to do is you have to fetch the major and the minor numbers, okay, and place it in private data field in struct file. Rest is transparently right now, we'll see later. Okay, so let's do it. Let's try to open the device, where we should be able to fetch the major binary number and place it in private data field in struct file, which is a stream representation kernel data structure. Yes, Srikanth, please tell me.
Structure inode and CDEV structure pointing to the same file operations. एक ही स्ट्रक्चर से वो तो कर सकते थे, फिर भी दो क्यों लिया? एक से तो point
Because the
करना।
interface to the struct file operations is your device driver. This through inode is an interface to the file system. So when you access the struct file operations through struct inode, you are actually providing an interface between the file system and the struct file. Same thing when you do through struct cdev, you are providing an interface between the kernel components and the device driver file operations. So there is an interface from the file system to the struct file, and interface from the kernel data structure, which are accessing the hardware, to the file operations, and then your interface becomes complete, and you are able to access from the file system to the device. That's how it happens.
तो जो सर ये सब मेथड्स है, ओपन रिलीज राइट रीड, ये दोनों के पास रहता है, मतलब inode के पास भी और CDEV के पास भी। दोनों
Yeah.
स्ट्रक्चर में अवेलेबल रहता है।
It's always available. Sorry, can you repeat that, Shrikant?
सर जो
Ashish, tell me.
ओपन रिलीज रीड राइट जो मेथड से
Yeah.
इम्प्लीमेंटेड जो सिस्टम कॉल को इम्प्लीमेंट किया गया है, तो दोनों के पास वो अवेलेबल होता है, आइनोड के पास एंड
Okay.
सी।
हाँ हाँ, कंटिन्यू श्रीकांत, मैं सुन रहा हूँ, आई एम लिसनिंग।
सर मैं बोल रहा हूँ जो फाइल ऑपरेशन इम्प्लीमेंट किया गया ड्राइवर में, जो मेथड्स है वो आइनोड एंड सी बोथ दोनों के पास ही वो पॉइंटर्स अवेलेबल हैं, सेम मेथड्स को
हाँ,
पॉइंट करते हैं।
that's right. This is an interface from the file system, and this is an interface from the kernel. So struct file operations is a device driver part which is being configured and designed by us. It needs an interface from the file system where the application will be able to use it, and further down to the kernel, so that the kernel could facilitate the operations being implemented through these routines. So it needs an interface from both.
Yes.
Now, inside the device driver, we have to create a local dev of dev underscore t type. No, dev type. You have created a kernel data structure. No, user defined data structure in declarations.h. The data structure that you created in your device driver is called dev. You create a dev type pointer here, say local dev. It's a local one. Now you have to prepare this local one such that it fetches the major memory number from here and stores it in private data field. It will not be like simple assignment. You will have to prepare along with the assignment as far as the coding is concerned.
सर मतलब पॉइंटर लेना था सर, उसमें सिंपल वेरिएबल लिया।
So what you will do is you will provide an interface here. You will provide an interface. There are two interfaces that has to be signed. So it is not a simple assignment. We have to use many functionalities provided by the kernel right now to provide these assignments. For example, when you talk about this file system, the file system has a name which has a struct inode associated with it, and all the attributes of struct inode has to be made available to the kernel module. All the attributes of struct cdev has to be mapped to the appropriate values in the struct inode. These details is beyond the scope of today's class, but there is a macro that is provided inside the kernel which we will use today, which will provide all the necessary interfaces here to here. And what are the interfaces that we will study in coming classes. So the macro that we'll be using to interface this portion, the green with the blue, I mean the interface from the file system struct inode to file operations, and another interface from struct cdev to file operations, and this interface will be inside our device driver provided through a macro provided by the kernel called container of. This container of macro, the details of the container of we will discuss later on, but yes, it will be used to provide an interface between the file system, struct inode, file operations, and struct cdev, file operations, so that the interface is totally complete from the application to the file to the inode to the file operation to cdev and down to your hardware device. Container of macro. Now this container of macro takes 3 arguments. Let's go there. Container of, here it is. Container of macro takes 3 arguments. Okay, the first is the pointer. to the member in inode. Let me explain it here. The container of this macro would be used to complete the interface between file system and file operations. And kernel with file operations. Okay. Now the interface will be complete from the file system to the file operations to the struct dev and the cdev and the underlying hardware device. It will do more than this. I'll tell you the other part later. The very first argument is important. And try to understand, नहीं समझ में आएगा तुरंत पूछना. About the first argument. This. About the first argument. Yeah. It refers to struct cdev through inode, referring to the part of interface that is from file system to file operations. ऊपर वाला इंटरफेस जो ग्रीन में दिखाया था मैंने, the interface that I showed you in green. Okay. Then
सर यहाँ पीटीआर सर साइड सर यहाँ पीटीआर में जो वीएफएस से जो पॉइंटर पॉइंट कर रहा है उसी का एड्रेस वही
किससे पॉइंट कर रहा है? cdev को पॉइंट कर रहा है.
यस
Through inode means I am talking about this.
ओके सर.
The other one type. Now watch this also carefully. This is the data type of the user defined device representation data structure declared in the device driver. In our case, dev, struct dev. सिर्फ उसका data type देना है. This data type has to be specified, which will tell you that what is the data type of some a data structure in kernel and device driver in which you will keep the interface. Okay. So this is the data type of that, and this data type is called container. It is called then the third one. Member. This is the reference to the device representation kernel data structure, that is CDEV, through the container for the other part of the interface, the blue media. Okay, so this is how it has to be used, and it returns a pointer to dev. Okay. Now from now onwards, this pointer will be the pointer that will be used to access the device, which will be also have attributes of struct file. Struct file means attributes of stream. Struct file, attributes of stream, which will represent the stream between the app and the device. The container of have abstracted many details from you right now. For the sake of simplicity, I'm not getting into that right now. Okay. So when we go inside of a device driver, we have to use this container of macro. First, we'll have access to the CDEV field inside inode. So let's go to inode and see what is the name of the CDEV field inside inode. Struct inode. That is CDEV field inside inode. What is it called? Here it is. I_CDEV. We need a pointer to it. I_CDEV. I_CDEV, which will be accessed through inode pointer. It is inside inode, isn't it? Inode pointer have come as an argument. Points to I_CDEV, which is a pointer. Now, from where do you get inode? Well, in the open system call of the application, we have given the file name. Every file in file system have a struct inode associated with it. It is that inode that got passed down here as an argument. The second argument of the container of is only data type, dev. See, this is the data type you used, isn't it? And the third argument is a name of the member of type CDEV, a reference to the device representation kernel data structure of type CDEV through the container, means through the dev. So inside dev, you have mentioned C_dev. So this is C_dev. Just to cross check, do you need a pointer? The name of the member within that, you don't need a pointer. So just see this member, is this member a pointer? Just have a look at this, what you are going to create. This macro is actually a function. Inside this, it creates a pointer of void type, no types, some bug checking. Okay, after bug checking is done, then after that, this pointer minus offset of data type minus member, so and convert it to appropriate type that you have given, that is your dev. So we will explore this further when we go into opening. Okay, for now, like, this is what we have done. Pointer to cdev, the data type that you have created inside your device driver, and the member inside your device driver device representation structure, which is going to refer to cdev. In our case it was c_dev, so we have taken c_dev. Okay, now it will return a pointer of type ldev. So as Hitesh was saying, sir, ये pointer होना चाहिए, he's right, it should be ldev local dev. Yes, Shrikant?
यस सर कंटेनर ऑफ में जो पीटीआर है मेंबर, तो दोनों स्ट्रक्चर दोनों मतलब डेटा टाइप सेम है क्या दोनों का? दोनों के सीडेव है पीटीआर एंड मेंबर.
Are you talking about this and this?
यस.
Yes, data type is same because both are referring to the same data structure. Both are referring to the same data structure.
So it
See,
is
this is also referring to the cdev, and from struct dev also you will be referring to such same struct cdev.
yes, I'm saying that it is mandatory to give the same data types.
Obviously,
Both.
otherwise the mapping will fail. Okay. Check for errors. Report errors if any. EWR log level changed, and you say in uppercase that it's an error, and then you'll say container of failed, isn't it? And then go to outer label from where you'll exit your program. There should be one exit point inside.
Sir, Hitesh this side. Sir, I had a small question. In the first argument of the container of, we are passing a pointer, which points to I_cdev. Sir, ये cdev का हम लोगों ने एक structure बनाया था. ये inode p क्या signify कर रही है? Is it made by us?
inode
Yes,
p
sir.
is an argument, first argument of my development. It resembles
Okay, sir.
the file operation. Open system call will give the file name.
Yes,
Every
sir.
file have a struct inode associated with it,
Yes, sir.
and this is that inode which is associated with your file name that you want to.
Fine. Okay, understood.
Nice.
Excuse me, sir. Line number 15, there should be a delimiter after out.
So at this point, if the container of is successful, then the interface between the file systems inode to file operation and another part of the interface that is from kernel data structure cdev to file operations, the interface will be complete. And before we proceed further, we must check it. We need a header file here, kernel.h. Very important header file. A lot of things in this that we need. So let's close everything and test if our container of is working properly or not. Then we can, if container of is working properly, then only we can proceed. Test. Build driver, of course. Yes. There it is. Insert driver into the kernel, number 2. Okay. Do you want to insert driver? Yes. The driver is inserted and is visible in list of modules. There you see, right at the top, char dd. 236 is the major number, which is visible here. 230. So, there it is. 236. My cat. that is char dd list of modules, enter major number 236. Okay, now we can build applications. Number 5, yes, application build is successful. And number 6, test driver with applications. Do you want to run application? Yes. The node, this is the file I am talking about, which is this file. The control will go, open system call control will go to your device driver and not to ordinary system call routine, because this file is a device file. As you can see, it's a character device file, not an ordinary file, and it has the major number through which it will go to the device driver and the minor number through which will further mature to the device. Now we are going to run the application. One for open device. The name of the device is my dev. Enter. Oh, why is it 237? Did we give 237 by mistake or what?
Yes, sir.
That's a mistake. Can't do that. Again, test driver with application. Yes. No, can't do that. Hold on, I have to do it manually now. Shell is changed. Got it. 6, test with application. Yes, 236 is done now. Right? My dev, it's correct. Go ahead, run the application. 1 for open device. Enter device file name my dev.
Two
236 is correct. And then it says enter device open mode. See, the major number was 236. Enter device open mode O underscore WR only. Okay, so I think the open should be successful. If open is successful, we'll be able to see, yeah, yes, open device is done successfully, and no errors reported. That means our container of is working well, isn't it? 2 for close. Let's try the same thing for read now. 1 for open the device again, my dev. Enter device open mode O underscore RD only. Okay, and again there is a release and open happened again, so no errors. Everything is working fine. 2 for close again, and 0 for exit the application, and see if the close happened successfully. Yes, it was good. So we'll exit, remove driver from the kernel. Point number 4. Yes. Must check the device table. 236 got. And then 0 for exit. Well, the first step taken successfully. Oh no, I did not take that step successfully because the container of is not tested yet, because I forgot to save this file. So saving it now. Now container of will be tested. Sorry. So we have to redo it. Test 1 build driver. Yes. Okay, 2 insert driver. Yes. 236. $236. 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 36. 2 build application number 5, yes. Then run application number 6, yes. One for open device, enter device file name my dev mode o_wr only. Yeah, open is successful. Then after that 2 for close is successful. Then after that open again. Six, test application, yes. 2 open device. Again, sorry. 6, test driver with application, yes. 1 open device, enter device file name my dev o_rd only. So open is successful. I gave a wrong input earlier, that's why see the bug over there. Now 2 for close, release happened, and then exit the program, done. Remove driver from the kernel, point number 4. $236 is gone, and then 0 for exit, done. So container of is tested. Any doubts you have regarding container of? About internal implementation of container of, should not ask now, that I'll tell you separately in another class. Today you should understand the 3 arguments that are given to container of, and you should be able to understand the return value, LDEV. Yes, Deepak?
Sir, what does a container of do exactly, like in
Just
this?
just before you ask this question, I say that the internal implementation of container of related doubt should not be asked now. It will be explained in the later classes.
Okay, sir.
Shrikant.
सर कंटेनर ऑफ जो यूज़ कर रहा हूँ किस लिए कर रहा हूँ, डेव को तो मुझे पता है डिवाइस ड्राइवर में जो डेव क्या है, तो उसका फिर से मतलब पॉइंटर लेके क्या करने वाला हूँ, मतलब
डिवाइस ड्राइवर के अंदर पता है कि डेव क्या है।
यस सर।
पर आप मेरे को ये सोच के बताओ डेव क्यों है?
सर डेव एक डिवाइस है, नीचे हार्डवेयर का एक्सेस करना।
नहीं, डेव एक user defined data structure.
Yes sir. Yes.
Declared inside your device driver.
Yes sir. According to the
in
device.
which you will have all the hardware device attributes.
Yes.
And you will have a glue to 2 interfaces. One interface is the green interface that comes
yes.
from the application to the file system to the file operations. Another interface is the blue interface that is within the kernel. From within the kernel it comes to your struct file operations. 2 interfaces. So struct dev will keep that glue, through container of will create that glue and connect these 2 interfaces, so that you have interface from the application, file system, struct inode, cdev to hardware. And that glue is container of macro, which is being implemented inside your driver, and the interface is now known through LDEV. Understand?
सर अगर
there is yeah, tell me.
नहीं सर, इसका अभी पूरा मुझे समझ में नहीं आ रहा, क्योंकि डेव तो मुझे ऐसा लग रहा है जो डिवाइस ड्राइवर में डेव को तो पता है, वो जैसे ऊपर से सिस्टम कॉल आएगा उस हिसाब से तो ड्राइवर काम करेगा, लेकिन डेव को क्यों मैप कर रहा हूँ हम लोग फाइल सिस्टम के साथ?
डेव को फाइल सिस्टम के साथ मैप नहीं कर रहे हैं,
जो आप ग्रीन
फाइल सिस्टम के साथ मैप नहीं कर रहे हैं। स्ट्रक्ट cdev को स्ट्रक्ट फाइल ऑपरेशंस के साथ मैप कर रहे हैं। The struct cdev is being mapped.
तो वो तो ऑलरेडी मैप्ड है वो inode से cdev.
We are mapping the struct cdev, which is a kernel data structure which represents the device. The device will be ultimately be referred through the struct cdev only. Device तक हम struct cdev से पहुंच सकते हैं। struct cdev हार्डवेयर डिवाइस तक जाने का रास्ता कर्नल के अंदर struct cdev से होता है। struct cdev is a kernel data structure.
Yes.
Struct file operation is also a kernel data structure, but all the function pointers has to be initialized by us for our own driver routines.
Yes.
Ultimately, struct file operations को दो इंटरफेस देने होते हैं.
Yes.
So there is something called kernel.
सर बिना कंटेनर यूज करके रिटाइट कर नहीं सकते क्या?
I'll come to that. Here you have file system. Inside file system you have a file. This file will have associated inode. So there is some application that will run in the user space. This application will try to open this file. The control will go from here to inode, and we have also created a file operations, strict file operations, in which you have driver routines. Now this is going to be one interface. You have implemented your device driver. Inside your device driver, you have declared dev, and inside kernel you have another data structure called cdev, which will access the hardware. So you have an interface from the file system, RFS root file system, to inode to file operations. एक इंटरफेस हो गया. दूसरा एक इंटरफेस, second interface will be this interface, which will be within the kernel. Okay. These two interfaces has to be linked. Then the interface from the application to the file system, to inode, to struct file operation and associated routines, and to cdev, and the access to hardware will be completed, and this link will be stored in your device driver. The application would have created a stream which you would learn. Okay, a stream representation, new kernel data structure will be created, struct file, and this link will be stored in struct file, which will refer to the stream. Now look at the interfaces. This is the complexity. You may not be able to get it in one go, which I am telling you today, but don't worry about that. I will ensure that through discussions and different perspectives that I'll give you, you will be able to understand all these interfaces. Don't get scared about the interfaces. Actually, this is not difficult, it is just new to you.
Yes, sir.
Excuse me, sir.
Yes, Ravi, tell me.
Yes, can you open that pointer?
Which pointer?
In the code. Yes, sir. What is this I_cdev? Can you explain again?
Okay. Inode, which is struct inode pointer. Inode points to I_cdev. I_cdev is a field inside struct inode of type struct cdev. Inside struct inode, you have this field called I_cdev, means a reference to character device. Okay, it's a reference to character device. You get that?
So, we actually need that pointer to that character device.
As far as this black interface is concerned, interface number 1 is concerned, we have to refer to reach to this. Okay. Hold on. There is a mistake here. This one interface and that second interface, and from struct inode you also have a reference to this. So this is 1A and this is 1B, both together constituting the first interface, and this is second interface. We have to complete file operations, struct file, struct cdev, struct inode, and the user defined data structure struct dev. All 5 data structures will be linked in this way. There is a complete class, one more session which we'll have to implement. मैंने कहा था ना आज implement कर लेते हैं, फिर अगली क्लास में जब हम बात करेंगे तो हमें समझ में आएगा कि हम क्या बात कर रहे हैं. So this is layer 1 of learning, layer 2 of learning. In layer 1 of learning, we have just shown you some implementation. In layer 2, I will explain each and interface, every interface in detail. When I will talk about layer 2, what are these interfaces, then you will be able to understand tomorrow, okay, what I was doing yesterday. Yes, who was that? Somebody is asking something.
सर दिस इज श्रीकांत सर.
Yes, Shrikant.
सर ये अभी जो इसमें डिस्क्राइब किया, इसमें कौन सा पार्ट पहले से मैप रहता है, कौन सा पार्ट ओपन होने के बाद मैप होता है?
कोई भी पार्ट पहले से मैप नहीं है. This interface, the black interface, was created when we did MK node. No other interface was available. One interface was available, that was this one, that we have done when we did cdev init and cdev add. The black one was prepared when we did cdev init, and the file operations we mapped separately. Now container of has taken all the 5 data structures together and provided these links where we complete the interface from the application down to your hardware, and the stream representation separate data structure is prepared struct file. Okay, so it is not possible now for all of you to have a complete understanding. You have a fair bit of idea and some confusion. Okay, hold on, tomorrow we'll take up each and everything, and when I'll talk about this tomorrow, then you'll understand, okay, what I was doing yesterday. If I would have not shown you this, then my tomorrow's discussion would have been like, going above the scale. You would not understood that, right? So